Hello, welcome to your new class to Android programming. In this class, we will learn about debugging. You may have had a prior experience with debugging in your prior programming experience. So some of this stuff may look familiar to you and you may want to escape it. However, my advice is to still watch the video and hone your debugging skills. For those of you who have never programmed on Java or who have never used an IDE before, this video is very critical to watch. What we will learn in the video is that how to debug an Android application and how to take help of Android Studio in debugging an application. Debugging is a very important skill for programming. If you cannot debug your program effectively, you cannot ever be a very good programmer. This is a skill to master, and current day IDEs provide a lot of help to us in debugging our applications. We are going to learn how Android Studio makes it easier to debug Android applications. So, first some basics. In Java, we already have a way to control our error behavior. That is using the exceptions. Using the exceptions, we can either make our program ready to handle errors, or we can simply trace it back to the point in the program where the error occurred. An important step of that is to maintain the information about exception and the corresponding stack traces. We can log these stack traces and then trace it back to the error that we are facing. We can also set breakpoints in our IDE so that we can enable line by line execution of the code. Android Studio also provides us something called exception breakpoints, where we can set the breakpoints depending on where an exception may occur. Today we will see all of this in action with our Android Studio and with our programming application that we have developed. Let us start. Let me start the Android Studio. As you can already see the emulator. Let's go back to a math quiz application. So this was the application that we have developed. This is also an application which is submitted for your assignment, so you are very familiar to it. However, let's run it one more time to see its behavior. The next changes to the next question. True or false gives whether the answer given is correct or incorrect. And as you see that even if I rotate, now the question does not go back to original. So the application is working perfectly fine. Now, let us restart our Android Studio and introduce some bugs. Normally during application development, the bugs appear naturally because either we oversee them or we unknowingly introduce some things, for example, not writing a correct line, not initializing our variables correctly, etc., and which introduces the bug. So let us see, since our application was fine, I will introduce a bug deliberately. I am going to comment out this line, and now I will execute my application to see what is the impact of commenting out this line. So let us be ready here and execute our applications. Let's see. Oops. So this time our application crashed. This crash was not happening earlier, but because I commented out this line, our application crashed. Sometimes you may have seen similar error on Android applications that you have downloaded from the Play Store. These errors happen because the programmer oversees an error which he should have corrected before releasing the app. The aim of this video lecture is to make sure that you do not make the same mistake, and then you debug your application thoroughly before you release it to the Play Store. So let us go through it. If I look at it, I can see that there is some red portion in my Logcat window. The Android Studio, in a very helpful manner, helps us create if I see my Logcat window, I can find that there is some red text here. This is Android's way of telling us that some exception has occurred. Now let us go through this and try to find out what happened. So I hope all of you can concentrate here on the bottom screen. It says Android runtime fatal exception main, gives the PID, gives the process, and then it tells the exception that has occurred, java.lang.runtime exception, whose brief description is unable to start activity component info. And then it goes on to the detail at different lines. If you have already programmed in Java, you should know that this is what we call as stack trace. So the Android Studio has dumped all stack on us, and we have to find out where the error occurred. A good way to find it out is to keep going through the trace. Now, we have found a line which says caused by java.lang.nullPointer exception, attempt to invoke virtual method, gives the name of the method, on a null object reference. So what it is trying to tell us is that we tried to run a method on an object which was not initialized. This has caused the null pointer exception, which has caused the ultimate runtime exception. So while debugging, you need to keep going down to the stack trace till you find a line called caused by and try to read it from there. Now the next line gives us the line number where it has occurred. Let me click on it. If I click on it, it shows me this line. And as you can see that I had commented the line just before that. But what was in the line that I commented? If you see in that line, I was actually assigning m2 button variable the actual object using the find view by id method. Now because that line was commented, m2 button was never initialized. And in the next line, when I tried to call set on click listener on my m2 button, I got a null pointer exception because m2 button is currently null. And invoking on it resulted it into the null pointer exception, which then caused the runtime exception and our app crashed. So if you are getting an exception in your Android, keep going through this stack trace, find out a line called caused by, see the next three lines will give you a very good hint. The first line gives me exactly the line number where it is occurring. Try to look upwards of that line, because that line was where it is pointing was executed. So the error must have happened earlier. In our case, this was easy to find out and we could see that. This is a simple example of what we call logging stack traces. Now let us go back to our Android Studio again and start setting some breakpoints. Now first, let me clear this error, and hopefully if I run my application should run once again perfectly. Let's see, and as you see that our application is working fine. Let us stop the execution and learn more about breakpoints. So what is a breakpoint? A breakpoint is a point in your program where you want the execution to stop and you want to have a look on how the program has progressed so far. Breakpoint setting in an IDE is a very useful technique for debugging because it allows us to go through execution line by line. Let us see how we can do that in Android Studio. The procedure is very much same also in Eclipse or in other IDEs. So, unlike last time where I introduced a bug, this time I will set a breakpoint here. For setting breakpoint, I have to do nothing except just click on the gray bar besides where I have written my program. So as you can see, I could see a breakpoint here. If I click again, the breakpoint disappears. If I click once, the breakpoint comes. The breakpoint is indicated by a red point. And if I hover my mouse, I can read a message which says that this breakpoint is on line 43. And on this point, the execution will be suspended. Now, in order to see these breakpoints in action, we will have to run our program in debug mode. The debug mode is enabled by pressing the button next to the green arrow. If you take your mouse to the green bug button, so this button looks like a bug. It says debug app. It can also be done by pressing Shift and F9. But let me press the debug button. Debug is similar to execution, except that it gives us more information. It stops at breakpoints and is a mode which is made entirely for debugging your application. Now when I press the debug, you can see that my window pane at the bottom has changed. Earlier I was getting logcat here, now I am getting debugger here. Not only that, but somehow my program came and the line where I had put the breakpoint is now marked as blue in my screen. You may get a different color. What it shows is that my program execution has now stopped at this point. Now this is also allowing me to check the value of different variables till this point. So for example, I can see that current index so far is 0. My mTrue button is null. My mFalse button is also null. There are some other icons shown here. First icon is step over, which I can activate using F8. The second icon is step into, which I can activate using F7. And then there are various other icons. I will mainly be making use of step over and step into. Step over is used to go over a line without going deeper into it. So suppose I am calling a method and my breakpoint is set to the point where the method is called. If I press step into, my execution will move into the method. But if I press step over, my execution will just move over to the next line. For the time being, let us just press step over. I have pressed step over, which means that now I have come to the next line. And see the impact. In this line, because I initialized my mTrue button, I can now see that among the variables, while the mFalse button still remains null, mTrue button has now been initialized. Let me press step over again. It comes into mFalse button, which is still showing as null. Press it again and my mFalse button has also been initialized because I am past this line. Now let me press step into. If I press step into, then it tries to go into the mNext button and mFalse button. I come out of it and I do step over again. I come to mNext button, which is still null. Do step over and my mNext button is also initialized. So my execution is going line by line. Now I have removed the breakpoint from its earlier position and I have added a new breakpoint to my update question. I am running the debugger and my application is displayed here. Now you know that update question is called every time we press the next button. So let's press the next button and see what happens. The moment I press next button, my question is not changed because my execution is stopped at the line where I had added the breakpoint. This is a wonderful opportunity for me to check what is the current state of all the variables that I have defined. So I can go to this window and I can check the value of the variables. For example, currently it is showing that my current index is 1 because my current index has been changed and now it needs to update the question. In order to move forward, I will press the resume button. So this is the resume button. I press the resume button and as you can see that our question is now changed. Our program is in execution again. Then I press the next button again. Again the execution stops. I press the resume and my question changes. So this shows you correctly the power of a debugger and a breakpoint. You can set the breakpoint and you can control your execution, making it to stop at each line if you want it to. Let us now move on to the third topic, which is the exception breakpoints. First, let us stop our debugging. I stop the debugging and now I will go to the top menu. So at the top I have a menu item called run. Inside run, towards the bottom I have something called view breakpoints. Let me click it. When I click view breakpoints, I see Java line breakpoints and I see Java exception breakpoints and I see exception breakpoints. As you will see that in Java line breakpoints, it is already showing the breakpoint that we have added. We can also see it here. Let me first remove this breakpoint. Now I don't have any Java exception breakpoint. Defined, I have now only got exception breakpoints and Java exception breakpoints. The idea behind exception breakpoints in Android Studio is that sometimes I may not know where my exception is being thrown. That is, I may not know where I should add my breakpoint. So the Java Android Studio helps you in doing that. So let me press the plus button. Among the menu, let me check the exception breakpoint. Or let me check the Java exception breakpoint. It will show me a new window. And as you know that last time when we had commented out our initialization of true button, it has thrown us as a runtime exception. So I will set my exception breakpoint to runtime exception only. So I have said that for Java blank.runtime exception, I am setting a Java exception breakpoint. This is a way to say that if in my program anywhere a runtime exception is to be thrown, please set a breakpoint just before that. Now let's go back into our code and make sure to introduce a bug that last time resulted into a runtime exception. I've done that now. Let me now debug my application, and as you will see, I have not set any breakpoints manually. Now let me run my application in debug mode. My application starts, launches, and as you see that even without adding a breakpoint, my execution stops at the line which last time has resulted into runtime exception. This is the beauty of exception breakpoints in Android Studio. They take away the need from the programmer to define the right places to set the breakpoints. This is a very good feature which you should use frequently in your programming, especially if you are getting exceptions and you do not know from where they are being thrown. Using exception breakpoints, you can find such points. However, as a good programmer, you should be defining your own breakpoints and you should work out with that to make your application bug free. Let me uncomment the part, stop the execution and try to run my application again with the same exception breakpoint set. And as you know, or you may have guessed, this time our execution doesn't stop because there is no place in our program which may throw a runtime exception. So this was all about debugging in a dynamic context, that is when your program was running. Whatever we have discussed can simply be used for any Java program or for any other programming languages because the principles of the debugging remain same. Now we will go into some Android specific debugging that is provided by Android Studio. One of the technique that is provided by Android Studio is a static analyzer called lint. A static analyzer analyzes your program statically, that is without running the code. Static analysis is a very important branch of software engineering where we try to find out that how a program can execute by just looking at the source code of the program. You may want to know more about static analysis of programs. Please try to find a suitable book or resources which tells you that. For our course, we will only cover the lint static analyzer as given by Android Studio. So let me open the Android Studio again. And let's go to something called Analyze. In the top menu, you will see this item called Analyze, and the first item is Inspect Code. Let me press the Inspect Code. It further asks me what do I want to inspect. So I am choosing whole project. Let me press the OK button. When I press the OK button, my static analyzer starts running and I see following result. As you see, it gives me result on multiple dimensions: performance, security, usability. For example, it is even figuring out small design considerations such as that the button should be borderless. So how does the lint do it? Well, the lint has a very good understanding of Android Studio and how we should write Android application. It uses that knowledge to analyze your program code and flags you some warnings. Lint is a very good tool to look when you are deploying your application to the Play Store and try to take into account the warnings generated by the lint. Now let us see what else lint can help us with. Let me go back to our code, and instead of this line, which I will comment, let me try to assign it a different ID of say question text view. Now this is a button, but I'm trying to assign it an ID of text view. Save the program and I run my lint analyzer. This time you can see that it is giving me an error saying mismatched view type, because it could figure out without even running my code that I am trying to assign a text view ID to a button. So these are some other errors in which lint can help us. Let's make our program right again. But even besides this, The lint is very good in giving us good advice on usability, security, performance, internation, correctness, etc. Now, let us go back to our last topic of the debugging class. Many of you have already faced issues with r.java file, and these errors are very difficult to debug. In fact, there is a very good reason why r.java is not made visible to you in the first instance. But still, if you happen to run into errors with your r.java file, here are few steps that you may take which may help you in making your life easier. Number one, the first step when you are getting a problem in r.java is to check the validity of your XML files. As you know that you define your resources in the XML files, and those resources will have a corresponding resource ID in the r.java file. Sometimes it's the validity of your XML file that is causing the error. So the moment you start getting error in r.java, go back and check if your XML is valid or not. Some other techniques that you can use is maybe clean your project and rebuild everything from the zero. Sometimes it gets rid of the errors. Then you may also sync your project with Gradle. So you may go here, you can go to run, you can go to the build. Here is a clean project which I was talking about, and this is the sync project with Gradle files. And then if nothing works, then try to run the lint, find out if lint can give you an appropriate warning to solve your r.java. This was all for your today's lecture. As usual, I have used references from Beginner Trench Guide and Developer Android websites. Debugging is a very important concept, and today we learned how to debug a Java program in general and how to use Android Studio for debugging Android applications. With today's lecture, your basic training as an Android developer is complete. You have created an application with a single activity. You know how to log and find out about what activity lifecycle currently the activity is going through. You know basic debugging techniques. You know basic UI techniques. Now and onward, we will move fast into the advanced topics. So far, the pace of learning was a bit slower to let you come up with the new programming environment of Android. But now I will assume that you have done your homework, you have created an app, and you are ready to delve into the advanced concepts of Android programming. Thank you.